Ah, this bloody stupid thing here. Right, okay. Wow. I don't even want to budge. Hopefully this one will do it. Okay. There we go. I can't smell any. It looks as though it's clean windings. Right, to connect the leads together, I'm getting a reading of 0.1 ohm. So what I'm going to do is go for the from the each lead and go into the armature to see if I get any reading at all. 0. If one's 0, they'll all be 0, of course. Nothing. It didn't even budge. Okay, between phases we got 0.11, say, or rather 1.1, 1.11 and 1.1. It's going to be extremely low value resistance because there's not a huge amount of turns, so not really a definitive test, but at least it wasn't totally 0. So this is the visual inspection of looks clean. There's no smoke deposits or anything in there. So, but a high voltage might have gone in and just pierced 2 windings, so I might have one shorted turn. That's a problem. Let's reassemble the motor. Okay, so we can put it back there. Easier said than done. Here's tight. Well, it's tight. There you go. Okay, so that's the motor set up. Another test for the motor is that he's actually spinning, he's cogging of course on the poles, but no resistance, which would suggest a shorted turn or a shorted winding. I don't know about a shorted turn so much. Okay, so our next test, I think we'll... Okay, what I have here is the motor connected up to a 60 amp ESC, and I'm running it off a little radio here and a GB Spectrum transmitter. Now what I'm going to do, I'm going to actually supply this with in stages to see what current is, in case it draws too much current. I'm going to supply this with first of all 8 volts at 3 amps. I'm going to try 8 volts at 3 amps. I'll turn the transmitter on and we'll be using the throttle. It might be connected back to front for all I know. Okay, applying power at this moment. Now? No, sorry, turn him on. Apply power now. It's continually bleeping now. That is a code for something. I'm not sure what it is. But you can see the motor light turning slightly. It might be because he's connected full throttle. Okay, we'll try. Let's try 12 volts. 12. Say 12 volts. I'm supplying 12 volts at 3 amps. See if that's any more suitable. Try the opposite way around. That's 2.3 amps at 12 volts. 2.8, 3 amps. Okay, so I'm confident enough now to actually remove that temporary power supply and maybe give it a, what's this here? This is a 3S power supply, right? Not working. Oh, is this reverse throttle? I think that's what it is. Yeah. I don't know if you can actually see this or not. I've seen a motor speed dropping. Of course, this I'm charged this battery for a long time, so I'm going to do exactly the same thing with a more recently charged battery next. Try that. Okay, so I think this is the most realistic test of all. Forget the oscilloscopes and everything. That's alright if the winding's gone, but you can see that normally with a ohm meter or even visually. But the thing is, if you got one shorter turn, you'll end up running hot. Something will end up running hot. Either the motor, more likely the ESC. So we'll zoom out a bit. So we got the transmitter, the gear in the background, and just show my trigger, and of course the ESC. If I can include the ESC here, and I'm checking that one for getting hot. Now, yes, that motor's quite warm, but then it would be, and it's uniformly warm. But the entire case is evenly hot, and he's going to get hot. I mean, there's some power going in there. Clearly, some amps going into that. Some watts is actually being fed in, because my 12 volt 3 amp power supply would only turn him slowly. So you could be talking about, well, we can check, we will check. I'll get an amp clamp meter. Okay, I'm gonna zoom right out. I'm gonna use my clamp meter. I'm gonna clamp on the power going in. You're going to have to take my word for it that I'm pulling the trigger and the motor is running. You have to take my word for this. Now amps, all I want to do is read the amps. Okay. That's 4.5 amps. .5 amps. That was actually 4.5 amps. As you can see, it's 4 to 4.5 amps at 12 volts, 12.5 volts. You have to take my word for it that that is the motor spinning. This is the trigger, throttle trigger, and this is the current being drawn. Okay, I'm going to do a ohms test on the RX on the cost of supply. I'm on ohms here. Let's see what we got. 1.6 ohms. It's a dead short cost of supply. And just to prove that, let's connect the power supply. You can see that. Right, if I put in this channel 1, 4.8 volts and adding 100 milliamps. That's 4.8 volts at 100 milliamps. Turn it on. Let's connect the lead. And we're taking 100 milliamps immediately, and the voltage has dropped to 0.18. Dead short. Okay, so let's turn the power off. Right. Huge overloading voltage. So what I'm going to do is supply it with a limited current supply, and basically not enough to burn anything, but the shorted component hopefully will get hot. So that's the plan of attack. 500 milliamps, and we'll turn it on and see what we got. See what gets warm, basically. So as this side of the board is getting warm, ow, something's out there. Ow. LFI. Well, I'll turn the power off. We'll clamp this in the holder here. So it don't move. And we'll try the evaporating experiment. So I'll turn over to the right. I'm just going to brush some IPA. That's all I've got available here at the moment over that side of the board, and then turn the power on. See what happens. Power's on now. Wow. Looked like that transistor. That little transistor looked as if he was taking a lot of current. And I'm going to zoom into this. Now the diode is getting hot. Where the coil? Yeah, the coil's getting hot because it's driving a short circuit. The diode could be getting hot because it's driving a short circuit. And the transistor's hot. He's getting pretty hot pretty quickly.